Hello, everyone, and welcome to Layer by Layer, the show where we break down some news of the week in 3D printing and the news of what we're up to here at Slant 3D. So first of all, the first note of this week. China is not cheaper than other places. So this is a really interesting topic, and it came up this week, and I want to talk about it because this is really, really important for people to understand because we see it in the comments all the time. China is not a cheaper labor market than the United States or really anywhere else in the world anymore. It hasn't been for many years. And I've known this, and this has been true for quite a while. The reason Chinese goods have been cheaper to purchase is because many of them have been heavily subsidized and because China is better at automation. So there's a couple things here. First of all, China is not cheaper. If you don't believe me saying that, please Google and look up Tim Cook. Tim Cook is the CEO of Apple, small company, you might have heard of it. He was at a conference recently, and he said, I do not know where everybody's looking, but China has not been the cheap labor market for many years. And he would know because they've been manufacturing stuff in China for a very long time. He said, China is not the cheap labor market. The reason we manufacture stuff in China, this is Tim Cook talking, he says, the reason we manufacture stuff in China is because we create very complex products. A smartphone is a very complex item that is a very specialized item and very difficult to manufacture. If we were to pull all of the tool and die engineers inside the United States together, professional tool and die engineers, they would fill up maybe a hotel lobby. But he says if we pull together all the tool and die engineers in China, they'd fill up a couple of football stadiums. There is more skill, there is more expertise, there is more talent around how to manufacture stuff in China than within the States. Yes, that is totally true. The United States in the 70s gave up on being builders of things. Because number one, at that time, it was cheaper labor seemed to be the issue. But the United States also did not choose to use technology in a way to benefit itself. Let me split that off to the side here. I'm going to get back to technology and robots here in just a moment. But in the U.S., we gave up training people in the trades. We decided that learning to be a machinist or an electrician or something along those lines, or even like mechanical engineers, seemed like a lesser degree to computer science and STEM and all the rest of this stuff. And what we did is we took out our manufacturing foundation right at the knees because we haven't been training new people. There's very few, precious few people inside of the States who know how to build stuff, physical stuff, real stuff, how to weld, how to bend pipes, how to put a car together, how to stick together a smartphone. It's starting to come back a little bit, but we are literally a generation behind. Because my generation, the millennials, were not involved in that at all. We run into this every day at Slant 3D. Having people who have deep technical knowledge around how to make stuff are pretty rare compared to the number of people in the country. And this is why China has a huge advantage and why China is a manufacturing hub for the planet. Because they decided, and other European countries have done this too. Germany is very good with trades, which is why they manufacture tons of stuff. But China decided to train their people to build things, as well as to program and that kind of stuff. They had a very intentional goal. And since that is where much of their GDP comes from, which is making stuff, they've continued to push into it. And since they make everybody's stuff, it's a career that can continue to be pressed on, and it's not thought of as lesser to be a pipe fitter or a welder or a machinist over there. So they have that skills base, which is a very specific and special set of skills that is not common enough on this side of the pond. So the reason everybody manufactures stuff in China is because the people over there know how to, whereas the people over here do not, just very bluntly. And this is an issue that is just pervasive. The other thing too, I was going to say about robots. China continues to be a manufacturing leader and continues to be affordable, even though their cost of labor is similar, because they have embraced the technology that enables this. The United States and many other countries have this really stupid dichotomy where, since we have no talent, we are required to automate. In order to get the work done, you got to figure out how to weld a car together with robot arms. But we also have a societal situation where if you bring in robot arms, you are accused of killing jobs. But if you don't bring in the robot arms, you can't make the stuff that creates the jobs. China does not have this problem. They have more robots per capita than most other countries, and they also have more per capita than most countries. The United States has 300 million people. China has 1 billion, or whatever the number is. But I think they have, I think the U.S. has 1 robot per 10,000 workers, and China is like 1 robot per 200, or something along those lines. I need to dig up that stat again, but it is very, very strong. China not only absorbs the most robots of any, well, no, actually, I think Japan might be ahead of China in using robots, but that's neither here nor there. The U.S. doesn't have very many robots compared to the number of workers, because we need the robots because there's no talent, but we're not allowed to put in the robots because it will scare off the talent. It will replace the talent, which doesn't exist. This is a weird catch-22 where we're not able to solve the problem of no people because it will create no jobs for the no people. It's so bananas and bonkers and really needs fixed. But and if you look at like manufacturing in other countries, if you look at it from a government standpoint, which I'm not a big fan of, but they will subsidize robots over there, whereas we do not subsidize robots here. If a manufacturer wants to pursue new technology and new efficiencies, there are no incentives to do so. There's no tax credit for a robot arm or anything else. It's literally only just about vilification. If a large company says, we're going to automate this whole factory, it's like, well, you're not hiring enough people. And here's the thing with robots replacing people. And I know many in the audience have heard this one before, but there has never, robots in their current state do not replace people. They are like a steam engine. Robots are literally just a steam engine. They will reduce the cost of goods so that there can be a higher rate of consumption or a higher rate of recycling, whatever it happens to be, and they increase the overall efficiency of the system. But the robots still have to be fed. Here at Slant 3D, we recently got a robot or two in, and we have a couple mobile robots running around. But like the robot arms, we have collaborative robot arm that we're messing with and experimenting with for our post-processing station. The reason being is that post-processing is an incredibly tedious task for an individual if they have to go through 10,000 parts and like remove a brim or something like that. It's expensive for the client and it's really miserable for the worker. But with a robot arm, you can train the robot arm to like debrim a part, and what the human can do is grab the part and hand it to the robot. So it's much less cognitively and physically intensive, but it allows the person to do what they do well, which is understand 3D space and work with the robot, because the robot does the tedious and precision job of like removing the brim, so it does a better job, but it's working with the person. What we did was take a normal person and make them 10 times more efficient because they don't have the mental fatigue or physical fatigue of having to do the hard part of the labor, and instead are able to focus on kind of sorting and what humans are really good at. This has been done by guys like... well, they did it early on at Patreon, and now it's Palantir. There we go. Palantir does this, where they have a hybrid AI-human system for detecting patterns and software bugs and fraud and that kind of stuff. But this symbiosis is what's really valuable. You can look at it, ChatGPT. ChatGPT kind of replaces a few people might, but really what it does is it makes like a single developer worth 2 to 3 developers, because now the single person is able to get better information and have the scut work done by the AI. And all of this just means that more stuff is made. Like if we're able to push more parts out the door, then we're able to make more parts. And if we're able to make more parts, then we can replace molding and so on and so forth. None of this is not a fixed pie situation. Expanding this efficiency through the symbiosis of man and machine has never created in this worse situation. Because if you make hard work easier by using these machines, then it allows you to do kind of miserable stuff more often. And miserable stuff is like sorting trash for recycling. You kind of need to do that with robots because a lot of humans just don't want to wade through dirty diapers to get to a plastic bottle. So this has to be done. But anyhow, sorry, that kind of went on a tangent a little bit, but robots are good. China is not cheaper. They're just better at manufacturing. And the US and other countries could get back in it if they actually wanted to use the technology available. We have the knowledge base to create better technological factories, but we need more pipe fitters and welders. So I really recommend, if anybody's watching this, if you're a kid in high school right now and you're watching this, do consider the trades. They're fine. They're great, if not better than a college degree. You don't have the debt. You immediately come out and you will make 60 grand immediately if you can show up on time and put a light switch in a wall for people. Literally, be a functional, useful human who is good at making stuff, and you will be so valuable compared to going to school and getting a degree that you're not a big fan of, was super expensive, and is not highly in demand. Caveat to that, if you are considering going to college because of something you're really passionate about and something you want to know more about, like this is your thing, study it more, and college can be good. But if you're going to college to float through and find yourself, please don't do that. That's a really bad decision. Okay, sorry. Yes. That's my small rant on that, but I read the notes before the show, and there's might be another one. So I'm going to temper this just a little bit. Update on Filament. Second batch of tangled filament is going out this week. So you should see shipping notifications of that. There was a bug in the shipping system that the team let me know about, to where there were some notifications early when stuff was being packed up. It was just stuff being packed up and having labels put on it, but it hasn't been picked up yet, which was weird, but I don't know what's up. But yes, the second batch is for shipping on the 22nd, is shipping on time, looks like. So that is coming together quite well, and then we will be done for the season because we are busy. We're really busy. So we will not be making any more filament this year. Caveat to that. We are doing recycled spools. So we are going to take other manufacturers' spools that run through our print farm, and we will be spooling transition filament. When you're like going from white to black and you have a weird kind of gray transition color in between, we'll be spooling that onto reuse spools and have like tangled reuse or something like that. That'll be like $1 cheaper or something like that, and available for just printing around in general, but you don't really care about the color. And we reuse another spool, so we can give you a break on that. But the material is still useful, and we can use the material too, but if you want to get a hold of it, you can. So that's Filament. We are working on, hey, if any of you guys are part of a filament extrusion company that's looking to get rid of an extruder, hit us up. We're looking for another one. So we will be expanding. We're working to expand our filament production capacity for the new year. So that will be coming down in January. And we got to see where, we all land at the end of the year on that, because we have a number of other projects. And yes, the master plan is still intact and that kind of stuff, and we can keep on doing it. But there's a lot of, from this first batch, we got a ton of really good feedback, and internal feedback as well about process management and stuff that we want to change about how we do this, to where we kind of want to, okay, cool, that was the test, tear it all down and let's start again one more time and do this right, because we're learning super fast. That. I have noticed that folks are still ordering the subscriptions. Any subscriptions will continue to be fulfilled, but there will not be batches released. That. Cool. Because the subscriptions, we can actually project ahead, and we can produce the stuff a month ahead of time and know what we're going to ship, so it's not a surprise or a big old job in the middle of the Christmas season when we're really busy fulfilling stuff for you guys through the Etsy app. The Etsy app and the software API, both of these give you direct access to our print farms. So here with Christmas coming up, everybody's going to be very often run into capacity constraints. If you have like a small print farm or that kind of thing, API v2 was actually finished up this week, and we're going into testing of it. We are going to finalize final testing of that over the next couple weeks, and then it will be integrated into the Etsy application. And the version 2 of the Etsy integration will be released early November. Early November. So it will be much faster on slicing, a lot cleaner. It's doing a full revamp. I mean, we're doing a full reground rebuild. The first one was practice, and we got it out there, and we got great feedback, and now we're going to relaunch the next iteration of it. So Etsy version 2 will go out, and then we will probably release open access to the API where you can pull an API key and put it into whatever project you're developing, probably early to mid-December. We might have to hold it until January, depending on where our capacity is, because we want to make sure that if you guys build something on us, we have the capacity available, and at Christmas, capacity is somewhat restricted. But it's reserved for like the Etsy integration and our existing users there. So we should have you all covered on that and should be good to go. All right. Other things. Testing lab. So thank you guys all so much for the feedback last week on the idea of a Kickstarter for getting a tensile tester into our facility to do testing on all filaments, infills, wall thicknesses, yada, yada, yada. Just getting really good data on 3D printed parameters. It looks like everybody's down for that. So right now, what we are doing is we are selecting the machine that we want to use. By the way, we've been doing a number of testing videos that have also gotten a really good response and I think have been useful to folks. Those are kind of our minimum viable product to see if people like the content that comes from that format. And it also looks like people do like that. So we will be getting a tensile tester in, tensile and compression. But based off our tests with those pieces, we're like, oh, we gotta get a big one. We gotta get a tough one, like bigger than we expected. We thought we would get away with like 1,000-pound tensile tester. And for tensile, maybe that would be fine. But like for compression, it's not even close because we were maxing out at like, I think it was 2,000 pounds or 1,500 to 2,000 pounds with a small solid PLA brick. And sure, that's a solid plastic block, but it wasn't that big of a block. And we need something tougher. We need like a real, almost hydraulic kind of press. But we're going for a big one. Big ones are expensive. So we will be funding that, but it gives you guys a way better video format. And yes, we will, what we've thought about with what we're going to do with the data is that, yes, we'll do videos around the data because that's kind of the main way of making it useful. But then we will also be turning the data loose, probably in just like an open Google Drive, where like the spreadsheets or the numbers output will be there. And if anybody wants to build a website around that data, which a few of you guys offered to do that, we'll make it open and available. Go crazy. And that would be fantastic because we don't have the bandwidth to do videos and a website and a blog and all this other dissemination. We can produce the data and we will pay for the space and the technicians and everything else and part of the machine, plus ideally crowdfunding, and we will give you guys the data and present the stuff that's interesting as often as possible. What the goal will be is to really quantify and qualify how FDM printed parts behave in all types of different situations. So we will like literally just run through the settings in a slicer and say, wall thickness, infill density, infill type, extrusion width, temperatures, blah, 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 blah. Just change every one of those variables and get how the dynamics change. Because it has to be done at some point in order for people to qualify parts. And it's a very useful data stash for anybody engineering around FDM printed parts. And since it's always been so, the FDM world has always been so sort of consumer focused, engineering data has not been necessary. But for what we're doing, mass production, and for people to be able to really utilize it at scale, we need that data stash. So we will be starting with that machine, and then long-term we'll build out a lab which will have thermal testing, UV testing, waterproof testing, all the stuff. I mean, we just started running off every type of environmental testing apparatus that we could possibly find in order to qualify these parts. And then part of it too, we will also be doing reviews of Filament itself. So like, here's all the colors of this brand. Here's all the colors of this brand. Here are all the materials from this brand. And here's how they compare over there. And then, yeah, we can go through and qualify our stuff too and just be like, yeah, our stuff is strong up to 100 pounds and their stuff is strong up to 200 pounds. They're better at it than we are, whatever it is. So that should do it. And some people have said like there's conflict of interest to this. This is a data analysis. It's like this part is this strong with this filament. This part is this strong with this filament. There's no way for bias to be in there. We can't say like, well, over average, their materials are a little weaker or something like that, even though they have a super strong and a super weak or something. There's no way to introduce bias into this. And yes, we make filament, but we make filament for a very narrow selection of black PLA. And that's all we're ever going to do. And as far as conflict of interest, I have no conflict of interest because I want to know what the strongest material is. As an engineer, I don't really give a crap where the material comes from so long as it does what it needs to do. And to lie to yourself, for us to lie to ourselves and say our material's better by fudging the data so that we end up lying to ourselves and saying we're going to use our material because we think it's better because whatever, rather than using the stuff that is objectively better from our test, which by the way, the test is public and known. There's no way I'm not going to be over there putting two scales on it or putting a thumb on the scale and saying, oh yeah, it was weaker. It's like, no, it was that strong. It was that strong. There's no way to introduce bias into that. And if for us to do so would be the stupidest thing in the world to do, because then it's useless to us too. We are a print farm. We are trying to mass produce parts. We cannot afford to lie to ourselves. If somebody else is making a material better that we need for an application, and they're doing it more affordably, if that's possible too, then that's the better option. So anyhow, quite frankly, I think that's ridiculous. The idea that us doing objective testing and being biased, we're not reviewing it. We're not saying, I feel like this one's better. No, it's just like, that's stronger, that's stronger. It's a number. There's no way to be biased. So I apologize if I come off as patronizing on that, but it's just sort of silly because there's no motive, no reason, and no way for that to occur. I guess I do kind of a sports voiceover when we do those videos, so I could say like, oh, that Pansy, whatever brand filament, it's not as strong as the Slant 3D filament. And I'd be like, okay, sure, that could be bias. But if it's weaker, well, it was weaker. But anyhow, and the number's there on the screen. You can check our videos. You can see the examples of this. But yeah, there's no incentive for us to lie to ourselves, or there's no way that tangled filament could be a biased answer unless we just did only testing of tangled filament, which again, we wouldn't do because we want to know if there's better stuff out there so that we can do our actual job better, which is producing parts in large scale with thousands of printers. I think I'm going to have more rants. This is going to be rant full video, and I apologize for that, folks, but this is what it is. Yep, rant full video. Here's the next one. The industry is too small. Okay. I'm getting on a lot of people right now, but I'm going to do it one more time. There was an article that came out this week, 3dprint.com, written by Joris Peel. Joris, I'm sorry. I like you fine, but you're wrong about this. He's not even wrong. He just was framed poorly. The article was called RIP 3D Printing 1987 to 2023. And Joris ran through how the industry growth has been basically flat in Stratasys. The industry as a whole is growing about 30% annually, but that's not amazing. It's not hockey sticking. We're not at that level. First of all, context. 30% growth in any industry is fantastic growth. Most industries rarely grow more than 5 to 10%. If you are ahead of inflation in an established market, you're doing fantastic. 30% compounded every year is a hockey stick. That will create an exponential curve. That being said, we are a super small industry right now. And he did bring that up. He said, yeah, we're $15 billion right now as an industry. we're stupidly small compared to the $500 billion of plastics manufacturing and $2 trillion of actual manufacturing overall. It's nothing, drop in the bucket, which, by the way, is why no 3D printing company should be competing with anybody else. There is unlimited runway. Go find some other river to fish in. It's like we've got all the room in the world to spread around. There's no reason to bite each other. But George said, yes, we built all these machines. We built all these solutions in search of problems. That I agree with. The industry has been so engineer heavy that all we've been doing is building machines, and nobody's been actually building what the machines are supposed to make. Which, by the way, is kind of the point of this channel, is to highlight products that are produced with printing and show how you can make them yourself in a way that is engineering focused and mass producible. Where was I? Yes. A solution in search of a problem. There's no doubt. Every problem that 3D printing is solving right now is already solved. Largely because printing also pegs itself as an alternative to molding, and we have had this problem too. 3D printing looks like an inferior version of molding. Whereas like, oh, it has layer lines, but I can make the same part with a mold and it looks better. That's sort of true, except that molds, you have the cost of molds and blah, 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 all this other stuff. But printing has not yet found the killer app, the items that can be made with printing that cannot be made any other way, that are very mass marketable. There's like dental aligners and those sort of customized items that have done it. But there hasn't been like a really mass producible item because customization won't do it. Customization is not an iPhone. Customization is an artisan chair. So it's expensive, it's slow, it's nice, but it's not great. Anyhow, but yes, there's a huge shortage of 3D printing applications. Huge shortage. If you are interested in getting into this industry, do not learn to build a printer. Learn how to make stuff with a printer. Learn what are products that can be created with this that cannot be created anywhere before. What needs an impossible geometry that doesn't exist. We look at hundreds, if not thousands, of these ideas every year. They pass my desk all the time from inventors, companies, organizations. And there are most definitely the applications out there. But the problem is many of them come from startups, and startups have a very high death rate. So there is always the danger. There's a very high attrition and very low success rate. But there are successes, and they're gaining ground, and they're gaining ground quickly. But as far as the industry having capped out, there's no flipping way. It's very obvious that 3D printing will replace almost every sort of manufacturing eventually. However long it takes, it's going to happen because 3D printing is a more efficient process, is a more definable process, is a more digital process, obviously, and is able to create items at scale, reliably, and affordably. With fewer inputs. You don't have the mold. You don't have the same amount of skill as like machining. So 3D printing will continue to absorb stuff. The problem is that so many 3D printer manufacturers are very heavily diluted. Desktop metal is called desktop metal, but they make freaking resin and wood printing and a shape molder and everything else. They're diluted. They're not pushing harder on making more watch faces. They're trying to absorb the market as a whole, which is a decent strategy, except that they didn't have a good foothold to start with. They're not that big of a company. When they're a $2 billion company making metal 3D printers, then they can expand into another market. Right now, they're shooting a shotgun at a wall trying to find out what sticks, which is fair when you don't have product market fit, which they don't have product market fit yet. And neither do we. Here at Slant 3D, we have the exact same machine making every part, but people wander in with TPU, PLA, ABS, carbon fiber nylon, the list goes on. And that dilutes us as well because there's not like a core focus. For us, the core focus is warehouse where the shelves make the product, which ends up going towards consumer products. How can we enable consumer products that are very highly variable, for like small businesses and Shopify stores. This really gets into like print on demand and like Etsy sellers, which is why we have the Etsy integration. That is really our core group, people making consumer products on demand. So they don't have to hold inventory. They don't have to have molds. They're able to create freely. We're an AWS and backend manufacturer for consumer products. That is where we see ourselves being most valuable. But being able to do it at scale, which printing has never been able to do before. So yeah, our thing is a warehouse where the shelves make the product. Every decision we make is through that lens. So even though we do filament reduces the cost of our production parts. Even though, yes, we do software. Well, software enables better optimization of the parts and connecting to us so that it's easier without having to call us up and connect this and do the shenanigans. How much easier can we give people access to scale so that you don't have to build a print farm and build all this infrastructure and figure out how to ship and what's the software and everything else? How can we allow people to make the applications, the solutions, the 3D printed products without having to worry about how it's 3D printed and shipped? That's the thing we care about. Everyone else, for the most part, is diluting themselves amongst building all the different processes and trying to be there when somebody comes along with a great idea. It's not great. And this is why the industry, but the other thing that the other issue that the industry has is that the industry is fantastically self-wound inflicting. I have never heard an injection molding engineer or a product designer who has control of their product really complain about something being 3D printed. It is always the 3D printing engineers who complain about it being 3D printed. It's like, yeah, we can make that part, but it'll have layer lines and this, and it's non-isotropic. It doesn't matter. Change the design to work with the process. And the 3D printing industry is the worst at that. None of us know how to change for the process. Everybody is trying to make a 3D printer make an injection molded part, which is putting a square peg into a round hole. And it's super irritating and unhelpful. Own it. We're 3D printing. We're not molding. We're never going to be molding. We don't want to be molding. Molding is bad. Molding is 100 years old, needs a mold, and creates all kinds of weird design features that are not helpful. But they're stuck there because of the mold. Now, I understand the market argument here is that, everybody's using molding. We can make printing a better pill to swallow by making it equivalent to molding. That's fine, but you again are watering down your solution because printing will never be the same as molding. So it makes it look like an alternative that's a little bit uglier cousin and also scary because it's different. So if you're going to be a little bit different, you might as well be completely different. So there's that. The industry is going to grow enormously. We're on track we will become a $100 billion industry by 2030. Easily. There's so much room to run and so little of it has been optimized yet. Because right now the industry is just in its own way. Literally in its own way. Somebody go out there, make a 3D printed product that's special. Figure out this. Here's what we're at. A printer is a transistor. We need somebody to figure out how to build a computer out of the darn things. Then you can make a whole bunch of them. That's where we're at. The 3D printer is not the PC. You don't want it to be the PC. And it's never going to be the PC. Nobody's going to have a home manufacturing device in their home any more than people have a bandsaw in their kitchen today. But having this core technology that is able to make stuff in a way that's never been possible before allows new capabilities and new products that have never been possible before. And many of them are really, really fantastic. And there are people who are working on really good ideas that will grow tremendously. And they will need the infrastructure to make stuff. So as a side plug, if you're a person making a product that needs to be 3D printed, that is really exceptional, please reach out to us. We're happy to help, and we will try to take a look and push you along as much as we possibly can, but you will have to pay us. So we are a service. But that's it, guys. Yes, the industry is really in its own way, and I'm really tired of the industry not being its own cheerleader. We have really fantastic stuff, but we don't own the fantastic stuff that we have. We're always just, it's like we've made this really square-nosed shovel and we're all trying to make people go dig a garden with it. And that's not what a square-nosed shovel is for. Anyhow. But that's that. So anyhow, that's the news. That's the rant. That's the stuff for this week, guys. Hope it was fun. Comment down below other topics that you want us to cover, and check out our other videos, either on design or our past podcasts here. And let us know if there's anything else that we might be missing, or add your 2 bits in the comments. Have a great day, everybody.